Okay, this is the P3 paper from January 2023. This is question number 10, which is the last question in the paper. And as you can see by looking at it, this is an exponential and logarithms question. In particular, we're going to be doing exponential modeling. It's question 10, so we expect it to be relatively difficult. Let's read through it. It says this is F stands for a population of fruit flies being studied. F is population. T is the number of days after the start of the study. We've got the equation there where K is a constant. Let's have a look at part A then. Well, it starts off quite gentle at least. The part A says, find the number of fruit flies in the population at the start of the study. A relatively typical question then, that's going to be just putting T equals naught, isn't it? So let's make a start with the question. We've got A at the start, T equals naught. There's only one mark for this, so it doesn't really matter what we actually go and show with this one. So F is going to be equal to 350 e to the 0, all divided by 9 plus e to the 0. So if you just stick all that in, we get that the number of fruit flies at the start is simply equal to 35. Let's have a look at part B. So part B says, given that there are 200 fruit flies in the population 15 days after the start of the study, well, that's going to give me F and T. And if it gives me those two things, the only thing I won't have is K, so I should be able to work out what that is. So again, relatively straightforward. We've got that F was equal to 350 e to the KT, all divided by 9 plus e to the KT. Let's tell the examiner what we're doing. So when F is equal to 200, we know that T is equal to 15. So let's sub everything in. I'm going to get 200 is equal to 350 e to the 15k, all divided by 9 plus e to the 15k. Although it doesn't look very nice, it's just simple algebra now to multiply everything up. So we're going to get 200 multiplied by 9 plus e to the 15k is equal to 350 e to the 15k. So it's just a solution of e to the 15k. Tied it all up, we're going to get 1,800 plus 900 plus 200 e to the 15k is equal to 350 e to the 15k, which then gives me 1,800 is equal to 150 e to the 15k, which means that e to the 15k, 1,800 divided by 150, which is 12. Lovely, got to a stage now where I can simply just log both sides here. So logging both sides, 15k is equal to log 12, and k is equal to a 15th log 12. And if we go back, what's really nice about this question so far, not bad for a question 10, is that they asked me to show that's equal to something. So I'm sort of expecting for part C to be quite tough, given those first two bits. So it says, given also that when T equals T, the number of fruit flies in the population is increasing at a rate of 10 per day. So hopefully you understand that if it's increasing at a rate of, that means df by dt. So they're telling me that df by dt is going to be equal to T. It's going to be equal to 10, and we've got to work out the value of T, the capital T there. So, right, that's not very nice to do. Let's make a start with that. So part C. Again, just make it clear to the examiner, just in case I make any mistakes. So the rate of increase, this handwriting, is equal to df by dt, which will equal 10 when t equals t. Okay, so what that means is, what did I have F as being? F is equal to 350 e to the kt, all divided by 9 plus e to the kt, and I've got to find df by dt. So I'm going to say u is equal to 350 e to the kt, and I'm going to say v is equal to 9 plus e to the kt, and I'm going to do this as a quotient. So I always do a quotient in the same layout, just means I'm, excuse me, less likely to make mistakes. So differentiating 350 e to the kt is going to give me 350 e to the kt multiplied by the differential of what's up in there, so multiplied by k. So that's 350 KE to the KT. If you're struggling with that, you need to go back and do some more work on that before you carry on. And then differentiating 9 plus e to the KT. Well, differentiating 9 doesn't matter. Differentiating e to the KT is e to the KT times the differential of KT. So it's KE to the KT there. They really shouldn't cause you any problems at this stage of your revision process, I would hope. So df by dt, I was trying to tell my students, write this down, guys. It v du minus u dv all over v squared, simply because it means you're more likely to remember that formula if you write it down every single time. For me, I'm less likely now in making substitutions in to make a mistake there if I've got it already written down for me. So v du, let's have a look and see what we've got here and just keep it nice and neat. I've got those two things multiplied together, v du, and I'm going to write that as 350 ke to the kt 9 plus e to the kt minus the other two, so that's 350 e to the kt times ke to the kt all over, and then v squared is going to be 9 plus e to the kt all squared. Okay, so let's see how much of this we can tidy up. We've got 9 times 350 ke to the kt here, plus 350 ke to the kt squared, and then minus. So yeah, actually looking at this, we've got, if we multiply this out, 9 times 350 gives me 3150 ke to the kt. But what I'm doing is just multiplying out this bracket, guys. Whoops. Just multiplying out that bracket there. So if I do that, I get that. Just making sure I've copied that down right. Plus 350 ke to the kt e to the kt, which is actually the same as that last term. So that's all going to cancel out. That makes me think I haven't made any mistakes, which is lovely. So what we're saying is that those two terms are both going to cancel there in a second, all over 9 plus e to the kt squared. I'll just write that down then. So that's 3150 k e to the kt all over my 9 plus e to the kt squared. I'm continually checking back to make sure I'm just not copying anything down wrong from one line to the next line. So this is df by dt, and we now know that that's equal to 10 here. Okay, so I'm going to get that 3150 ke to the kt is equal to 10 lots of 9 plus e to the kt all squared. Oh, so yeah, at this stage then, if I'm going to see it's equal to 10, so this is the point now where I can actually say this is at t equals t and at t equals t here. Okay, so really, again, let's not be lazy. I should do that up at the top part there as well. So that's t here is equal to that. So it's just going to be multiplying this all out and tidying all up. It's not going to be very nice, but it's going to be some sort of quadratic here by the looks of things. So this is 3150 ke to the kt is equal to, hang on, this is 10 lots of, multiply this all out first of all, just you take your time to do it. I'm going to do it quite quickly. E to the kt times e to the kt is e to the 2kt plus 18e to the kt plus 81 here. It's a good skill to be able to do a plus b all squared as a squared plus 2ab plus b squared. That's all I'm doing, but you take your time over it. Multiplying this all out gives me 3150 ke to the kt plus equals 10e to the 2kt plus 180 e to the kt plus 810. Now let's make that one quadratic on one side here, sorry. So I'm going to get 10e to the 2kt, and then with the I'm going to take this over to the other side here. I'm just going to do everything quite quickly now. It's going to be plus 180 minus 3150k, lots of e to the kt, plus 810 equals 0. I've simply taken that over to the other side, and when I've done that, I've just combined these two together. So at this stage then we're just trying to solve this quadratic equation. Why is this a quadratic equation? Because I've got, if we assumed that u was equal to e to the kt, then I've actually got 10u squared plus 180 minus 3150k u plus 810 equals 0. If we made that assumption up there. So what I'm going to do is to try and solve that quadratic equation. It doesn't factor, clearly it doesn't factorize. So we're just going to get that u is equal to, so u, which is e to the kt, is equal to, using the quadratic formula, minus b plus or minus the square root of blah, 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 blah. So that's going to give me minus b will be 3150k minus 180, just flip that the other way around, plus or minus the square root of that all squared. Do you know what, before I do all that actually, let's just divide everything by 10. I'm just looking at the constants and they're not very nice, and actually we could have called this u squared plus 18 minus 315k plus 81 equals 0. So just divide everything by 10. It's just going to make it a little bit easier when we're subbing values in later on. So yeah, u is going to be equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So that's going to be 315k minus 18, because that's minus b, plus or minus the square root of that same thing squared. This looks horrible, but we're just going to sub some values in a minute. In fact, I'm not going to do it. I'm going to let you do it. Minus 4 lots of AC. Well, that's just 4 lots of 81 now. All divided by 2. So this is E to the KT, capital T, is equal to E to the KT, just checking I haven't used the small t anywhere further up. So KT is just the log of all of that. Cheat using iPad here. And now just sub in. So sub in that K is equal to a 15th log 2. And they're not expecting, I'll tell you what the answer is in a second, they're not expecting you to get any exact values or anything. You're just going to sub that in now. T will be log of all that, obviously divided by the K, bring down the K at the last point here. But I'll just tell you what the two answers are, and then you can struggle through that for yourself. T works out to be equal to 5.7, and T works out to be equal to 20.8, apparently, by going ahead and then solving all of that. So, yeah, not very nice, very, very last part to that, but for a question 10, I think that's pretty reasonable. A and B were pretty straightforward, and even part C, as long as you realised it was this differential and you were able to get part the way through the differential, you're going to get enough marks on that to make that a pretty fair question. So hopefully that will make sense, guys.